Hello friends, I am Rahul S, Assistant Professor in Civil Department, Sandipani Degree Campus, Latur. Our today's topic is derived expression for slope and deflection at the free end of a candle beam subjected to point load at free end by Macauley's method. Now, learning outcomes. After watching this video, student will be able to understand the concept of Macauley's method, and also student will be able to find the slope and deflection of a candle beam subjected to point load at free end. Now here we consider a beam. This point load at a free end. This span is L. Suppose this is the end A and this is the end B. So here our aim is to find the slope and deflection at free end. So for that we have to first calculate the reactions. So here if you apply sigma Fy condition, so vertically upward is a plus and vertically downward is a minus. So now here this is a downward, so we assume here this reaction is the upward. So this is the VA. So upward reaction is a plus, so VA is minus P is equal to 0. So VA is equal to P. So this becomes VA is equal to the P. Next is we know fixed end have a moment. So here we are assuming initially this moment is in the anti-clockwise direction. So if our answer is a positive, that direction is the correct. Otherwise we have to change the direction. So now here apply the sigma MA is equal to 0. So clockwise is plus and anti-clockwise is the minus. So this anti-clockwise, so that is why is minus MA. Then at here A, this P force create the moment. So this is a clockwise, so P into the L. So plus P into the L is equal to the 0. So this MA is equal to P into the L. So what we assume direction is anti-clockwise is the correct, because this answer is the positive. So we can say that this is a P into the L. And this we know is a one horizontal reactions, but this there is no horizontal force, so that is equal to the 0. Then we know here the differential equation for the elastic curve EI d2y by dx square is equal to the mx. So first we write the mx here. So mx is equal to, now we consider here only one section, because one force and this is one force, so we have to apply only one section. In case of this Macaulay method, we are generally consider the x is from the left hand side. So we are considering the x is from the support A. So this VA into the x, VA is a P. So P into the x, that is a sagging bending moment. Then this moment MA, it's create the hogging bending moment. That is minus, moment is a P into the L. So we are not multiplying here distance generally, but in Macaulay's method we have to multiply by the x and make the raised to power 0. So that becomes the already x raised to power 0 is 1. So P into the L. Now put this value into this equation. So this becomes here suppose EI d2y by dx square is equal to P into x minus P into L into the x raised to power 0. So integrate this both the side. So integrate both side. So here this becomes EI dy by dx is equal to this P into x raised to power x square by the 2, then minus P into L into the x, this x to power 0 will become the x raised to power the 1. So this is the slope equation. But here one more here addition, that here one add here the constant of integration, the C1. Here we have to add one constant of integration, that is the C1. Then again integrate this, so this becomes EI dy by d. This becomes integration is the EIY is equal to this P into this becomes x cube by 3, and this 2, this becomes the 6, then minus P into the L into x square by 2 plus integration of C1 is a C1 into the x, one more add here the constant of integration. So this is the deflection equation. Now our aim is to find this C1 and this C2. For that we have to put the boundary conditions. So boundary condition. So first condition is, if x equal to 0, the dy by dx is the 0. We know x equal to 0 means at the support A, is at support A. Here the both slope and deflection both are the 0. So we are first putting here condition x equal to 0, the slope is the 0. So our this slope equation we have to put this condition. So left side is 0 because slope is the 0. Then this is 0 minus 0. So this becomes 0 minus 0 plus the C1. So C1 is equal to the 0. The next boundary condition. Again that we know x equal to 0, this y is equal to the 0. It means the deflection is 0 in this equation. So this becomes 0 is equal to, this is 0, this is 0, this is 0. So automatically this C2 is the 0. So in this way we got the value of C1 and the C2. Then next is our part, the slope at the A. Slope at the free end. Slope at free end. For that we have to apply the condition x equal to the L. This dy by dx we denote as the IB because that point is a B. So when if you put x equal to L, this dy by dx becomes the IB. So first we write here the slope equation, EI dy by dx is equal to P into x square by 2 minus P into L into the x. This is the equation because yes plus C1 is the 0. So we have to put here x equal to L and dy by dx equal to IB. So EI IB is equal to is PL square by 2 minus this PL. Instead of x we have to put the L. So this becomes into the L. So this becomes EIIB is equal to PL square by 2 minus the PL square. So this becomes here. So EIIB is equal to this PL square by 2 and minus PL square, this becomes minus PL square by the 2. So finally we can say that IB is equal to minus PL square by 2 EI. And this negative sign indicates this slope is a clockwise. This slope is clockwise. Now how the slope is clockwise? Look here. Now suppose this is the deflected shape. we know this is the delta deflection. That is, now if you draw here the one tangent at the free end, so this slope is a plus. That is why this is a minus, and this is our slope IB. This and this both are the same. The next part is our deflection. So deflection at a free end. For that we have to put the value of x is equal to the L. This y becomes the YB. Okay. So first we write here the equation of deflection. EIY is equal to P into x cube by 6 minus P L by 2 into x square. First we check here. This is Px minus PL into x square by 2. This 0 and this is the 0. This value is 0. This C1 into x and C2 equal to the other side of 0. So PL into x square. Okay. So now this EI becomes EI YB is equal to P into, this becomes the L cube by 6 minus this is P L by 2 into the L square. So EI YB is equal to PL cube by 6 minus PL cube by the 2. So finally if you solve this YB becomes minus PL cube by 3EI. So this is the final answer, and here this negative sign indicates deflection is downward. Deflection is the downward. So we can write here like this: YB is equal to PL cube by 3EI, and here show the sign downward. So this is the slope at the free end. Thank you.